Welcome to today's Icelandic National League of the United States presentation. I'm Rob Olafson, your host during this hour, and I'm glad you're joining us today. This webinar is part of the Icelandic National League of the United States mission to provide programs, classes, and other offerings that create connection points for Icelanders, people of Icelandic descent, and those interested in Iceland. Information on the INL US can be found on our social media sites, our blog, and our website found at inlus.org. If you're already a member of the INL US, we thank you. If you're not a member, I encourage you to join us. Your membership helps fund scholarships, grants, local projects, Icelandic language classes, and other initiatives. Before we get started, a couple of reminders. This program is approximately 1 hour in length and is being recorded. The recording will be available through the INL US website. As attendees to the program, you are muted. However, we welcome your questions and will answer as many as possible during the program. To ask a question, please click the Q&A button at the bottom of your screen. If you are on a phone or a tablet, the button may be in the upper right corner, or you may need to swipe to find it. On today's program, we explore an aspect of Iceland that has been turning up a lot in international news: the recent and ongoing eruptions on the Reykjanes Peninsula, which is a short car drive away from Iceland's capital and largest city, Reykjavik. To help us understand why this keeps happening on the Reykjanes Peninsula, we are fortunate to have with us geologist Shawn Willsey, who teaches at the University of Southern Idaho and is the author of the book Geology Underfoot in Southern Idaho and co-author of Roadside Geology of Idaho, the second edition. Shawn has also been providing extensive coverage of the eruptions on his popular YouTube channel, where he shares up-to-the-minute analysis. Shawn Willsey has been to Iceland 5 times to study and document the volcanic activity. In fact, he has just returned 1 week ago from his latest exploration of Iceland's Reykjanes volcanic region. Welcome, Shawn, and thank you for joining us today. We look forward to your presentation.
Great. Thanks, Rob. I appreciate that introduction. So I'm assuming it's all up to me now to get the show rolling?
Yes, you're in charge. We watch.
Okay, so hopefully everyone can see the slides okay. I'm sure Rob will let me know if they're not present there.
Yeah, great.
Oh, great. Thank you. So yeah, I appreciate the time to address your group this evening. Interesting to know about this organization, which I was not aware of. So that's been fun for me to learn more about your organization. I do not have any Icelandic ancestry that I know of, but I'm very much interested and I suppose very invested in Iceland and its geology and learning more about its culture and its people. So very happy to share with you this evening some of what I've learned about Iceland's geology. So this is a pretty ambitious presentation. We're going to cover more or less the last 4 years of Iceland's volcanic eruptive history. And I'll go through this as quickly as I can. There's a lot of images that I want to share, and then I'm happy to answer any of your questions you might have at the end. So let's just go ahead and get started right with this. And this presentation is set up in a way that if you have no geologic background whatsoever, I'll be sure to make sure that the level I'm presenting is a level that is approachable to just about everyone. So the first thing that at least folks like me need to wrap their heads around is just how big Iceland is. Certainly when I'm there trying to get from place to place, it can feel really big. There's no freeway systems. The highways tend to wind around the coastline or in and out of fjords and other landscape features. And so I was actually surprised when I looked up the size of Iceland and found that it wasn't nearly as big as I thought. It's about the size of Kentucky in terms of its size, if you want to compare it to one of the states. And as many of you know, it sits in the North Atlantic between Greenland and Europe. and is a really interesting place for geologic reasons. And that's why I was drawn to this area about 10 years ago when I started visiting Iceland. As many of you may know, Iceland's tectonic setting is quite unique geologically. It is both a divergent boundary where two plates are spreading apart, but it is also the home to a hotspot, a place where there's an enormously high amount of heat and magma rising from deep within the earth, deep within the Earth's mantle. And this is what's feeding a lot of the volcanic activity we see there. The whole island is about 25 million years old, so it's quite young. You can't find rocks on Iceland any older than that. And these two plates that are spreading apart are moving at about a centimeter per year, which is pretty slow by human standards. But when you give it, millions of years, you can end up accomplishing quite a bit. And this, of course, is part of the Mid-Atlantic Ridge, one of the few places, and probably the most prominent place along the entire Mid-Atlantic Ridge, where the plate boundary is exposed at the surface and is above sea level. So that's a little bit on just the overview of the geology there. Looking a little bit closer at Iceland, we see that there's several volcanic zones. So when we look at the individual volcanoes in Iceland and plot them up along with their associated flank eruptions or secondary vents, we end up with a map that looks like this. And predictably, this more or less tracks the hotspot. And so you can see the hotspot coming in from the southwest on the Reykjanes Peninsula, moving across the Reykjanes Peninsula south of Reykjavik into the interior, and then exiting Iceland here off the north coast of Iceland. There's this other interesting little arm here that extends to the south and goes down to the Vestman Islands and the Isle of Heimaey, which had an eruption in 1973. And I don't want to get too deep in the weeds here, but this is essentially a location where the plate boundary is sort of transferring from one arm, from this southwesterly arm here, what we call the Western Volcanic Zone, over to this one. So in the future, many thousands, if not, hundreds of thousands of years from now, we'll see the plate boundary actually extending more or less through this region here, and will over time start to wane in terms of its location here on the Reykjanes Peninsula. But for now, this is still quite volcanically active, both in terms of eruptions and also tectonic activity. We also have this kind of anomalously different region on the Snæfellsnes Peninsula here on the west coast of Iceland. So this gives you a little feel for where the volcanoes actually are, at least the very recent and young ones here in Iceland and their distribution. Focusing a little bit more on the Reykjanes Peninsula, it's drawn a lot of times as just a more or less the east-west line that parallels the peninsula, but that's sort of just connecting the dots and not really telling the whole story. What we really see in terms of both faults and volcanoes just distributed throughout the Reykjanes Peninsula is a series of southwest, northeast trending faults and fissures that just march their way sort of stepping sideways throughout the Reykjanes Peninsula. Once you get into central Iceland, it gets a little bit more complicated because we have bigger, more what we call central volcanoes, big stratovolcanoes like Katla or Hekla that occupy that area. And so this is a little bit more straightforward here, but the tectonic and volcanic activity we see here is 100% related to the movement of these two plates, but it's not as simple as a straight line you could just draw across here. The straight line you sometimes see coming across the Reykjanes Peninsula is just someone you got to put a line on the map somewhere, and that makes the most sense. But in detail, it's really these sort of right-stepping, offset segments that define where most of the volcanic activity and where most of the earthquake or faulting takes place. The other interesting thing about the Reykjanes Peninsula is, and you can maybe tell a little bit with my homemade graphic here, is that the direction of plate motion, which I do have on here pretty accurately with the North American and Eurasian plates, notice that these red lines, these tectonic and volcanic zones, aren't perfectly, for the most part, aren't perfectly perpendicular to the direction that the plates are moving. And so this is not a perfectly what we'd call an orthogonal or perpendicular set of faults and volcanic regions. There's a little bit of sideways motion, or what we call strike slip motion as well. So it's a little bit leaky. It's not as perfect as just the plates separating laterally on either side. But this is where we expect, and where we have seen in the past, the bulk of both the eruptive activity and also earthquakes in the region, is along, not perfectly these red lines, but these swaths here. I probably should have made these red lines a little bit broader. And of course, the interesting place that we're looking at over the past, I guess, 8 or 9 months or so, is this arrangement of volcanoes, and what we'll see are faults that lie just to the north and east of Grindavik. So a little bit better view of the systems there. So as humans, we like to classify things and give things names. That's how we make order and sense of our chaotic world. And so this is the names of the various volcanic systems in the region. So the furthest west one is the Reykjanes system. This one's kind of lumped together two systems, the Elverp and Svartsengi system. This one we'll talk a little bit about, the Fagradalsfjall system, Krishuvik, and then you can see these other ones here going off to the east. Most of these zones also have shallow geothermal regions, which are shown with the dashed lines here. So near the tip of the Reykjanes Peninsula, there is both surface geothermal activity, hot springs and bubbling fumaroles, but also power plants, geothermal power plants. This, of course, is the one of interest as of late, the Svartsengi power plant, which sits in here. There's another system here, which I don't think is exploited for geothermal power, but there's a geothermal area there you can walk around. Looks a lot like Yellowstone, called Seltun, that's just on the west shores of Lake Klevervat. And then there's these other ones up here. This one is a big one, and going into the town of Hveragerði, there's a big geothermal power plant there as well. So this is where we see the bulk of the volcanic systems on the Reykjanes Peninsula. But the more we're learning about these volcanoes, and especially looking at their chemistries, the more we're seeing that they're quite related. So there's a good argument to be made that instead of having 6 swaths running across this graphic, that they're possibly fed by the same deeper magma supply, and maybe it would be better off lumping them all as one. But nonetheless, just because of their geographic distribution, they've often been sort of categorized or labeled as these separate systems you see here. If we look at the eruptive history on the peninsula, just sticking with those same 6 zones, this is a graph looking at when we see eruptions that have taken place on the Reykjanes Peninsula, going back to about 3,500 years ago. And so we have a limited archive. We can only sample and look at the rocks that are exposed, or rocks that we have encountered by drilling into the ground. And we do have quite a few of these geothermal boreholes where we have some subsurface data. So I wish this went back a lot further, but this is all the data we have in this region thus far. And what we see is a pretty interesting pattern of, I don't know if I'd call it cyclical, maybe episodic might be a better term, but these little yellow bars on each system, and these are still arranged here going across the top of the graph from the west side of the Reykjanes Peninsula, moving across to the east in the Hengilt system over here. But each little yellow bar is a period of volcanic eruptions. Now, that doesn't mean that it was erupting continuously during that duration, but it was having or experiencing on and off eruptions during that time period. So you can see some of these bars last a good 500 to 600 years, just on and off eruptions that are going on for hundreds of years on the Reykjanes Peninsula. You can also see there's a pretty well-established pattern here of quiescence. So there's also periods of time, again, 500 or more years, where the systems are quiet and there's no eruptive activity, no volcanoes erupting on the system. And they all seem to go off at about the same time interval. Again, not exactly the same eruptions taking place across the whole region, as far as we can tell, but at least during the same interval, there seems to be eruptive activity across most, if not all, of the systems. And then you can see the most recent spate of eruptions here that ended about 800 or so years ago. So this is what's interesting, is this region, the Reykjanes Peninsula, including some of the suburbs on the south and eastern sides of Reykjavik, the capital area. All this area has been developed and has been modernized over the past, let's say, 100 or so years in the complete absence of any nearby volcanic activity. And now we're possibly seeing the system entering this new phase, this new episode, round four, if you will, of an eruption period on the Reykjanes Peninsula. And so the tiny little yellow bar here, this is a weird system. If you were to ask most geologists prior to 2020 or 2021, where's the next eruption on the Reykjanes Peninsula going to be? I doubt many people would have pointed you to the Fagradalsfjall area. And yet that's exactly the place where we had eruptions occur starting in March of 2021. And now what we're seeing is the Svartsengi system, or the Svartsengi system, is starting to show signs of activity over the last 8 or 9 months as well. And so it's an interesting pattern. I guess what I want to point out, though, is it does seem episodic, which is kind of not what we typically see in most volcanic systems. And the best explanation we have so far, we're still learning a lot, there's limited data, is that perhaps the stress builds up on these systems. It's all being pulled apart, of course, because it's a divergent plate boundary where the rocks are being extended or stretched. And then once it really breaks sufficiently, that's when you get this influx of magma through that broken rock and up towards the surface. And so it does, it does bear further scrutiny and more analysis. And I wish we had, another 10,000 years of data to add to this graph, but that's kind of where we're at right now and what we know for sure. So there's very good likelihood that what we've seen happen on the Reykjanes starting in March of 2021, that's definitely, I think, a harbinger of things to come over the next few years, decades, and possibly even centuries. So just characterizing some of the eruptions we see on the Reykjanes Peninsula. Iceland is home to many different types of volcanoes, but on the Reykjanes Peninsula, they come pretty much in just a few different flavors. And so all the rock on the Reykjanes Peninsula tends to be this very dark rock called basalt. This type of rock comes from lava that is quite runny, it's hot, it's low in silica, and it's generally non-explosive. So if you want to live next to a volcano that's not going to erupt violently and create a lot of ash, this is the type of volcano or lava to be able to deal with. And this type of eruption here is what we call a fissure eruption, where the volcano erupts from fractures or cracks running through the landscape, usually parallel to those northeast-southwest trends I showed you on the previous map. The gases that are dissolved in the lava will push the lava out, sometimes creating large fire fountains or curtains of fire that can reach hundreds of meters into the air, depending on the force and volume of the eruption. And then as that lava collapses, it'll feed lava flows that will flow outwards and down slope. And these can last sometimes only for a few hours. They can sometimes last weeks and sometimes months, and not so much in Iceland, but in some severe cases around the globe, these sometimes can go on for years and even decades, but that's much more the anomaly than anything. So we usually see fissure eruptions. A lot of times these fissure eruptions over time, though, will consolidate into just a few vents. So it's not often that a fissure will remain open and will erupt in that way for days and weeks. You can tell where we've had fissure eruptions in the past when you drive around Iceland by looking at some of the rocks in the landscapes. And when you see these very interesting sort of fins or fingers of rock that cut across the rock layers here, these are what we call dikes. These are the conduits that bring lava up to the surface. Sometimes they don't make it to the surface. Sometimes they run into a rock type that's too hard and they terminate. But those that do make it to the surface are what we call feeder dikes. And on the Reykjanes Peninsula, as well as many other places in Iceland, there's fantastic exposures, usually along the coastline where you have the sea cliffs, sometimes where the glaciers were, where they cut big cliffs into the rocks as well, where you can see these dikes. But these are evidence of fissure eruptions. So it's interesting to note that sometimes these big, huge curtains of fire that look like and are very impressive are sometimes controlled by a conduit that's maybe only half a meter across, just a few feet in its terms of its thickness. So a lot of times those fissure eruptions will actually consolidate into a few vents. And once it starts pumping out of one centralized vent, that lava that's erupting will also often form what's called a spatter cone. So it still has gas content. The lava is still being ejected up into the air. That lava is sticky. So when it lands around the vent, it stays put for the most part. And over time, it builds up this cone, this steep-sided cone, not very tall, maybe just a few tens of meters tall. And it will just continue to build upwards as long as the force of the eruption can cause the lava to clear the rim. If you can get the lava up to the rim, you can build the spatter cone higher and higher. But they do have a finite height. I've never seen one over maybe, oh, I don't know, like maybe 100 to 150 feet or so. They're not going to create mountains per se, but they will produce pretty interesting and steep-sided landforms. And I actually went through one of the webcams that was up today. I grabbed some shots of what the only spatter cone, the only vent that's erupting today, June 6th, north of Grindavik, is this one here. This one in the background's kind of died out. And what I did is I just went through the webcam's kind of made a time-lapse footage of the different points in time over the course of the day. And what I want you to do is kind of focus on this rim here on the spatter cone, because spatter cones, they construct themselves taller by lava piling up on the rim, building it upwards. But at the same time, in the center of that spatter cone is a steep pool of magma or lava that sometimes causes collapse. And so it's this back and forth battle between processes that are trying to build the spatter cone higher, and then other processes that are actually trying to create its collapse and its demise. So watch this little rim here. So here's the first little image I have. And then there was a little bit of a collapse. Hopefully you kind of caught the little change in the silhouette there of this cone. These are all within probably, I didn't timestamp them all, but this is, let's say, within 8 to 10 hours time. So keep watching the rim of the spatter cone. There it is, built back up. So this is the next sequence. So it had built back up and smoothed out some of that jagged skyline that it had there. Occasionally it's throwing up the spatter, so you actually get to see that. So that's a nice vigorous outburst of lava, all that stuff. Some of this stuff might land straight back down, but the lava that lands near the rim of the spatter cone will continue to build it up. But keep watching that silhouette or that skyline along the rim there again. Then you can see it's jagged. There was another collapse there. And if you're watching it live, I mean, I just picked some screenshots, but if you watch this with the camera, you actually do get to see it in real time collapsing and changing. And sometimes the collapses are bigger than this. The ones that I caught from today are fairly small. But watch the rim again. And now you can see, let me go back one there. Notice this section of the spatter cone here just drops away. So this creates a bigger notch right here in the spatter cone. And then going into evening, you start to see the glow of the lava field in the foreground, and it's coming out both sides of the spatter cone. So there's this kind of convecting pool of lava in the crater of the spatter cone. Because the spatter cone's not very strong and it's very porous and permeable, the lava just tends to leak out the base. So some of it does kind of roll down the sides, but most of the lava coming out of this thing is coming out the base. And in this case today, it's coming out both the north and the south sides of the cone. So I thought that would be a fun way to just kind of show you how these spatter cones evolve. And then occasionally we get much more long-lived eruptions that can produce much larger, broader volcanoes that we call shield volcanoes. This is one up near Gullfoss, in the Golden Circle tour area. And my Icelandic is terrible, but this is, I think, Skjaldbreithur, something like that. But you can see just how immense this shield volcano is. So this is just where this low viscosity runny lava has just poured out of that vent at the summit and just rolled down the hill and made this broad, not very tall, but this broad shield volcano we see here. It's called a shield volcano because if you look at it from profile view, it looks maybe like a Roman warrior shield lying on the ground, just a convex type of shape there. So let's move into what's happened on the Reykjanes over the last 3 or 4 years. And Iceland really has been as Rob said, in the news a lot, the international news, because of some of the exceptional eruptions that have happened there, some of the behavior of the eruptions, and most recently, the threat that these eruptions have posed to infrastructure and to an entire town. So I'm going to skip through these pretty quickly, but we could have easily spent an hour looking at each one of these eruptions. So from 2021 to 2023, there were 3 discrete eruptions. They all happened to coincide with the summer, which is nice for the tourism. And these were in a remote area of kind of highlands here, just to the north and east of Grindavik, called the Fagradalsfjall eruptions. And these were considered the most tourist-friendly eruptions you could visit. I can't think of a better situation. You land at an international airport, you rent your car, you drive half an hour, park your car, and then hike a few kilometers, and there you have it, along with maybe a couple hundred people or more. So these were incredibly scenic. They were relatively safe because they were kind of trapped in these valleys and these highlands. The local search and rescue and civil defense kept an eye on winds so that the volcanic gases were always moving away from the people. So there was, some measure of safety involved. But for the most part, as long as you could hike in there, you could enjoy these eruptions more or less, to your own personal satisfaction. These were, if you wanted to see lava, this was the best time so far to have seen it up close and personal. And 2021, I missed it, and I was kicking myself that whole year, like, gosh, I should have went. What's wrong with you? And that eruption in 2021 lasted 6 months. So the next summer, when it erupted in 2022, it was the perfect time. It was early August. I had a few weeks before I had to get back to the college here and start the semester. And so literally the day it started erupting in August of 2022, I booked a ticket and I was there within a week. And I got to see it up close and personal, and it was awesome. It was everything I'd wanted. I'd seen Hawaiian eruptions several times, but this was just really, really fantastic. So that was the eruptions at Fagradalsfjall that went into the summer of 2023. So now let's move into this past fall, and really the first signs that anything was happening in a different region. So just to kind of orient you here, this is the town of Grindavik here on the south coast, the Fagradalsfjall area where the other eruptions I just talked about were occurring. It's kind of over here in this higher, steeper terrain. But in the fall of 2023, we started experiencing strong, well, let's not say strong, but moderate sized earthquakes that did produce significant shaking that people felt. And quite a few of these earthquakes. So a large number of quakes. So maybe not huge in terms of magnitude, but large numbers in terms of frequency in this region. Here's the road going north towards the airport and Reykjavik. So there's the roadways you can see there. And they were centered more or less right underneath Iceland's #1 tourist attraction, which is the Blue Lagoon, which is only there because it's runoff, effluent, if you will, from the adjacent Svartsengi power plant. So they capture that hot water that's has a high silica content, a lot of dissolved silica. They pump it over to this kind of low area in the lava fields, and people started soaking there in the 80s and 90s, and now it's a major attraction in Iceland, the Blue Lagoon. So interesting location, right? Of all the real estate in Iceland, why are we having earthquakes right underneath our #1 tourist attraction and very close to this fishing town here, Grindavik? So this is from October to November. So the first signs were the earthquakes. We also saw signs of magma movement and migration up towards the surface, looking at ground deformation. So this is something called INSAR. So this basically is radar that goes over an area twice. It does 2 passes. So it went over it on October 28th. Made the same pass November 6th. This is satellite based, and using the differences in the radar signal, they can detect movement of the surface down to millimeter resolution. And so you can see here the big bullseye. There was about 70 millimeters of uplift, 7 centimeters of uplift just within that week and a half or so period, right there underneath the Svartsengi power plant and the Blue Lagoon area, just north of Grindavik. So this was obviously cause for alarm. This was about the time I started monitoring the situation quite closely. I was looking at the data just for my own interest. And then one day I had a crazy idea that maybe I could record a video of what I'm seeing and looking at this scientific data. And that really was of interest to a lot of people. And that's where my sort of YouTube videos really took off in a major way. So we had this data. We also had GPS data. So there's a number of GPS stations in the area. And what GPS stations will do is they'll measure the movement of the ground in 3 different dimensions. So this top graph here shows how much the ground moved in a north-south direction. The middle graph shows east-west movement of a specific location. And then the bottom graph shows vertical motion up and down. So you can see, and then at the bottom scale here, this is, they're not labeled, but this would be, let's see, this would be September, October, November. So this is a 3-month period, about 90 days. So you can see it kind of going up and down, but nothing, that's all probably just within air, just normal kind of ground fluctuations. But then you can see going into late October, early November, this pronounced movement downward on this top graph. So northward movement is up or positive numbers, which means that downward movement is movement to the south. So this station started moving to the south. If we look at the middle graph here showing east-west motion, we could see not much happening, maybe a slight westward trend, but then it significantly started moving to the east. And then more noticeably and possibly more alarming, not much vertical movement until we get into the end of October. And then you can see this rapid uptick in the movement of the ground going into November. So this was alarming to the scientific community. It was clear this with the earth, along with the earthquakes, were clear indicators that magma was moving up into a shallower reservoir beneath the power plant in the Blue Lagoon. That was causing the rocks to stretch and expand and not only move just upwards, but also move outwards. And so when we plotted all the GPS stations up, you could see exactly where the doming was caused by the magma body. And this continued into early November and so people were feeling these earthquakes. The earthquakes were magnitude 3, 4, sometimes 5s, but it really reached a fever pitch on November 10th. If there was a dramatic moment to this phase of this period on the Reykjanes Peninsula, it was November 10th. And November 10th was when the earthquake intensity increased by a significant margin. So you can see all these circles here. Circles that are about this size are probably magnitude 4 to 5. I didn't put the scale on there, but you can just see a lot of circles there. Most of these bigger circles are earthquakes people in Grindavik and surrounding communities would have felt. And as we looked at the pattern of those earthquakes, they quickly delineated this northeast-southwest trending lineament here, and this was interpreted as a magma intrusion. So magma moved out of the storage zone underneath the power plant, shifted underground to the east, and then probably took advantage of an existing fault system or fracture system and injected that magma into a 15-kilometer long linear trend of magma in this zone here. You might ask, well, why didn't the magma just come straight up under the Blue Lagoon? And all we can really say there is, for whatever reason, those rocks under the power plant and the Blue Lagoon are very competent. They're stronger. They're maybe not as riddled with fractures. And so this was the path of least resistance, was for the magma to move sideways a kilometer or so, and then inject itself into existing fractures. And as it's pushing into those fractures, it's actually going to force them wider. And that's what's generating the earthquake. So remember that earthquakes are nothing more than rocks breaking. And rocks break when they're under stress, either from tectonic forces or, in this case, magma being injected and shoved into those fractures. And so the people in Grindavik were a little bit frazzled by all this activity, and the public officials had some really hard decisions to make here. And so the entire town was evacuated. There was a mandatory evacuation order issued, on November 10th. And so the entire town of about almost 4,000 people, or about 10% of the entire population of Iceland, evacuated. A lot of them went to family and friends' homes in other communities. Some of them went to shelters that had been set up, but it was incredibly smooth. and all done as smoothly and efficiently as could be expected, all within a single day and evening there in Grindavik. And what had happened then is so here's the town here, here's the power plant in the Blue Lagoon. As that magma injected itself into the subsurface, it came very close to reaching the surface. At the time and in the moment when I was watching all this data come in and the town evacuate, I fully expected, as I'm sure many others did, that an eruption was about to take place. But it didn't. And what we think happened here is that magma pushed up. If you look at this bottom diagram, you can see this magma dike as it comes up. It creates stress conditions above it that cause the ground to drop. And there's a little area of subsidence. And this little depression here is what we call a graben. And it's bounded by these faults here. And so we think that the magma came as close as about 500 meters or so of the surface. So it injected along a considerably long length, 15 kilometers, and it pushed upwards to almost the surface, but it didn't quite get there on November 10th. So there was no eruption, but the damage to Grindavik had already been done. The earthquakes and the formation of this graben, so these little sawtooth lines here you see outlined in pink, that's the margins of this graben. And I'll show you pictures here in a second of the damage that was done. As you can see, one side of the graben went right through the center of town. And we think it was because it was right over this dike here. So what this did to the town was it caused significant fracturing and cracks in the surface. It severed pipes, different utility pipes. This is near one of the main intersections in Grindavik. This is the sports complex right here. This is looking to the northeast. And even with so the good news was everyone was out of harm's way. The town had been evacuated. That was the right call. But the bad news was even without an eruption, the damage to the town's infrastructure was so severe that it was going to be a long time before people could move back into their homes. You can see some of the damage here. So these cracks, a lot of the steam coming out of the ground is where some of the hot water pipes were severed. So they were not going to have heating, no hot water. The electricity was cut off for a time as well. So even though there wasn't an eruption, the Icelandic community and public officials quickly realized that an eruption was likely, if not during on November 10th, then very soon. And they started coming up with these innovative plans that I've never seen done on this scale before. They put up defensive barriers around the critical infrastructure. And they started with the Blue Lagoon and the power plant, recognizing that this power plant supplies hot water and electricity, I think, hot water and heat to 20, 30,000 people on the peninsula. So these orange lines here are where they pushed up these big earthen berms or lava barriers or walls, whatever you want to call them, buttressed up against these prominent hills here, Sidingarfelt and Þorpjör. And Hagafelt. These are where these barriers were built, recognizing that, well, if it erupts inside this, well, it doesn't matter anyway. But if it erupts outside this zone, maybe these will divert the lava and keep it from going into this area, which is a low area. It sits in a lower space. And so these are what these berms look like in sort of from ground level. This is one at the Blue Lagoon, a picture we took just a couple of weeks ago. So they're up to 30 feet, 10 meters or so in height. They're very impressive. And the Icelandic people just did an incredible job of working round the clock with their crews and equipment and getting these up. And again, it's a testament to them and their grit and ingenuity that they were able to do this. I've joked with people before that if, this same thing had played out in the US, there would have been committees and debates and maybe the action wouldn't have been quite as prompt. But this all reached a head with the first eruption on December 18th. So this was the first eruption in this region. It was very large in volume initially. It lit up the sky here in the middle of winter when it's very dark at this time of year. And here's more or less where this occurred. So here's Grindavik down here in the lower left. Here are the eruptions from the 2021 to 2023 vents. And this eruption was along these dark orange lines here. These are the fissures that we saw erupt here. So it was further to the north. It was along this older called the Sunnuk craters. So these had erupted about 800 to 1200 years ago. So there were already fractures and weak spaces in the rock that the magma could exploit. And so it more or less reoccupied that same lineament when it erupted in December. So you can see the extent of the lava flow field here. Never even approached the defensive barriers around the power plant or the town. And so I think after this eruption died down after a few days, I think people were optimistic. I think people thought, well, if it keeps doing it this here, we might be okay. And maybe we can open things up eventually in town, because most of the people in Grindavik were not able to spend Christmas in their homes. The evacuation was still ongoing at that point. I drew a silly diagram here, but this just kind of shows the idea. This is incredibly cartoonish and simple, but the idea is that the magma is coming up from a deeper reservoir into this shallow reservoir or storage zone right underneath the Blue Lagoon and power plant area. But instead of erupting vertically, these rocks are just too strong. They don't have as much fracturing in them. And that magma is moving through some sort of pathway to the east and then moving upwards and then forming these eruptions that we've seen over the past few months. So that's just my little diagram that I drew way back in December to kind of explain to people what was going on. So what happened after December 18th is the eruption shut off after a few days. We started seeing uplift though, so we knew that the magma storage zone was inflating, more magma was coming up, and we were going to have another eruption at some point soon. And that took place on January 14th. January 14th, I remember vividly because it was my wife and I's anniversary. The eruption started my time here in Idaho at about 3:30 in the morning, and my phone was going off like crazy. And I rushed to school in a blanket of snow to get here to see what was happening. And the eruption wasn't in the same place as it was in December. It had moved further south along that northeast southwest trend, and it erupted just south of this hill here, Hagafelt, and part of the fissure was actually right through the berm. These yellow lines here are those defensive walls, those berms or lava barriers that had been erected by the Icelandic community over the winter. And so this one, luckily, a good portion of the lava was coming out of the northerly part of this fissure, so it was actually flowing around this lava barrier. It was doing its job. Some of it escaped to the south, but then there was another fissure that erupted down here closer to town. And let me talk about that one a little bit more, but let me show you a couple pictures here. So here's a picture looking to the northeast. You can see the fissure, the line of fissures there, some of it cutting through the defensive berm there. Here's the lava flow advancing to the southwest, and here they are trying to finish putting the rest of the material up along the roadway, covering the pipeline as well, before the lava reaches it. So just a truly heroic effort to, be trying to get this done while the lava is, not so slowly advancing towards them at the same time. So for me, this was pretty exciting, but it was also a little, I guess it was pulling at my heartstrings because I knew how close this fissure was to town. I knew the lava was advancing on both sides of the berm southward towards the town. And I had partnered with a drone company called Nature Eye, and they allowed me to operate their drones remotely from Idaho while the eruption was taking place. And on that day, early that morning for me, January 14th, while we were watching this main area here erupt, we were able to spot just to the south this plume of water vapor and steam that was coming out, almost looks like it was coming out near town. So we flew the drone down there, and what we caught was the initial phases of this vent opening up. It was really quite remarkable, but you can see how close it is to these homes here along the northern fringe of Grindavik. And at the time, no one knew what was going to happen going forward. It was it was drama of the first degree. Was this fissure going to lengthen? Because we've seen that before with previous fissures. Was another fissure going to erupt and open up further into town, or heaven forbid, in the harbor itself? And so we watched this fissure as it opened up. It started feeding lava flows. And unfortunately, that lava flow ended up consuming and destroying 3 homes here along the northern margin of Grindavik. But it could have been so much worse. Had this fissure stayed active and maintained a larger, erupted a larger volume of lava, this single vent could have wiped out a large swath of the town. But luckily, it only lasted for a couple hours at the most, and then it died down. And so this eruption, again, was a pretty short-lived eruption here in January. But this is the one, at least with the Grindavik residents I've talked to, this was a game changer for them, because this was the eruption where they realized that maybe they weren't as safe as they thought with that December eruption, that they knew that volcanoes could erupt very close to, if not in town. And that got them thinking in a sort of a different way about their long-term future in this community. So going into the rest of January, this eruption died down. The vents just shut down completely, but we started seeing inflation again. So the same thing we'd seen before. More magma was moving up. It was recharging. It was setting the stage for yet another eruption, and that happened on February 8th. So you can see here in this kind of dark red the outline of the eruption February 8th. Luckily, this one went back to the north and occurred close to the December vents. In fact, it very closely mirrored those December fissures. It did cut across the road going north-south from Grindavik to the airport, and so that road was taken out for a while. It also took out this pipeline. So the pipeline going from the power plant out to Keflavik and other parts on the Reykjanes Peninsula, that was severed, and there were people that were without hot water and heat for a number of days while they tried to get that repaired. So this was the eruption in February, another just spectacular eruption, but also another eruption that fizzled out quite quickly. A lot of these came in with a bang, kind of roaring like a lion, but after a couple days, they quickly waned after the first 24 hours or so. And you can see a Grindavik here on the far right of that image. There it is going across the road. This is the road leading into the Blue Lagoon. So that road was compromised, at least at that point in time. And then what happened going forward? Well, same thing. We had a period of quiescence, but this whole system was recharging. All the signs were showing towards another eruption. And on March 16th, that eruption came, more or less very close to the December and February locations, largely mirroring those. So thankfully, again, not down here where the January eruptions were. And so this eruption's shown in blue on this map. Again, it went back across the road that they had just repaired, but luckily didn't advance far enough to the pipeline area, which they had also covered. And so they were ready for lava to go there, but it didn't quite advance that far. Some of the lava, though, did come down to the defensive berms and flowed along this eastern wall. And there was concerns as that eruption was going on that that lava might make it down to this roadway here, the east road that goes out of Grindavik, and maybe even go to the ocean, which would have been a different set of hazards, because as that lava goes into seawater, it can become explosive. It can create aerosols and very toxic gases. And so luckily it didn't make it that far, but those were some of the concerns at that time. Quick view of this one here, the March eruption, another spectacular fissure eruption and the lava flow there. And this one was interesting. So this is where things changed a little bit. At this point, we kind of started to think we knew how this volcano behaved, because the December, the January, and the February eruptions were all very similar in terms of their behavior. But the March eruption didn't go out after a few days. It persisted. And this one little spatter cone kept going well into April and even into early May. So this eruption actually lasted, I think, about 6 weeks, maybe even more, maybe like 8 weeks or so. This eruption persisted much longer than what we'd seen with the prior ones. And if we look at the GPS data, you can kind of see how the pattern looks here. So here's the months of the year down here on the bottom. So everything gets started in late October. And I just plotted up here the vertical motion, the up-down, not the east-west and the north-south. So here it is, everything's moving up. So that's what we call inflation. The magma is building in the subsurface, causing the ground to rise. And then we had that first event on November 10th where the magma moved underground to the east and formed that big dike. So that's that first little deflection you see there. But then after the magma moved away from this location, it started inflating again quite quickly. That culminated with the December 18th eruption. So that's the next little spike you see in the data there. Then it started building again to the January 14th eruption. Another spike there. Same pattern going to the February 8th eruption. So you can see the consistency here. The March eruption, there's a little hiccup here because on March 2nd, there was some earthquakes and what we think was an intrusion. So we didn't get an eruption there, but we think some of the magma pushed its way and forced its way into some area in the subsurface. But then there's the March 16th eruption where it drops back down again. And then the inflation began. And that inflation was interesting because it was inflating simultaneously with it erupting. So it was erupting from one vent, one spatter cone, at the same time it was still inflating. So that's telling us that more magma is coming up from deep. And then that reached ahead with this most latest eruption, which began on May 29th. So you can see again another down drop there. And then since May 29th, there's been a couple interesting data points here where instead of going back up immediately, it's actually gone down a little bit. But in looking at some of the data today, it's actually starting to swing back up. So there's been a little bit of an uptick in that data. So to wrap this up, I was able to take students to Iceland in mid-May. So there's my class at right near the Blue Lagoon, and they're holding chunks of March 16th, 2024 lava. So this stuff is still cooling. When we were there, we could still see heat radiating off of it in the distance. Obviously, the chunks along the margin here were cool to the touch, but probably the youngest rock in their collection, I'm sure. So that's the March 16th lava there. And we were lucky enough to be able to get access into Grindavik, and my students were able to see some of the damage. And so I have just a couple photos here. I don't want to show anyone's homes, but at least I feel okay showing, like community buildings and other buildings. So there's some of the damage. This is the sports complex. You can just see how extensive some of the damage is there. Here's the lava flow, the leading edge of it that came in, that destroyed the 3 homes. And then littered all around the grass was little chunks of tephra. This is actually pieces of lava that were ejected during an eruption. This was the February 8th eruption. The wind during that time was fairly strong out of the northeast. So the town actually was littered with these little pieces of what we call tephra, just wind-blown little tiny pieces of lava that flew and then landed and had cooled at that point. But you can see them in the grass just kind of everywhere around the town there. So, and then of course, where was I on May 29th? I was in Iceland, right? When it erupted. What was I doing? Well, I had the bad luck of being out, well, good and bad luck, I suppose. I was out on the Isle of Heimaey in the Vestman Islands with a different group of YouTube viewers doing geology stuff and showing them around when that eruption began. So I wasn't able to see it up close and personal. They had things kind of locked down pretty tight, but this is that initial phases from the Coast Guard helicopter of the May 29th eruption. So this is our most recent eruption that's still going on right now, although it's definitely dropped in activity. And here's some of the damage to, this is the roadway. There's Grindavik's out here. This is looking to the east. And so this is the roadway that leads west out of Grindavik. So right now, as it stands, this will change quickly, I'm sure, but right now 2 of the 3 roads are covered in lava. But what they've shown the incredible ability to do quite quickly is go in, and even after this lava is still kind of warm, they'll just put gravel over the top of it, reestablish a roadway, and just drive right over this thing, just so they can have that infrastructure replaced. So there's them working on either the road, or maybe that's the berm there, and there's the volcano erupting off in the distance. So that's my presentation, just trying to run you through several months of activity in and around Grindavik on the Reykjanes Peninsula. Hopefully that was helpful in explaining the geology to some degree and giving you some insights. If you've been following this closely like I have, maybe this was mostly review, but hopefully there was some nice new nuggets of information there. So with that, I'll turn it back over to Rob, and happy to answer any questions folks might have.
Well, thank you for that presentation. That was just an incredible summary. I really enjoyed it, and I hope our audience did as well. And a reminder that if you want to ask Shawn a question, tap on that Q&A option on your screen and start typing away. There are a couple, well, there's one comment that I'm not sure what, the first comment we have is, what paper is that figure showing the graben compressing the dike tip from?
Oh, okay. Let me find it real quick. Oh, yeah, let me go back to, I can pull that up real quick, do a quick share again. let's see here. Right here. So I believe this is the bottom right here. This is the figure in question. Does that look right?
I think so.
Okay. Yeah, so this is the top one. The big graphic here is a map from the Met Office, the Icelandic Met Office. Yeah, I should have referenced that. Shoot, and I didn't. I'd have to look that up, but that is from another publication, another paper. I have that somewhere. I didn't actually put the reference on there, so I should have done that. But yeah, pretty it actually might be from, I actually know what it's from. Let me show you real quick here. I believe it's from, if you're interested in volcanoes and geology and you want one of the world's largest books, the Encyclopedia of Volcanoes, which is no less than let's see, 1,400 pages. So if you need a large paperweight or something to put you to sleep at night, or possibly some awesome reading material if you're interested in science. I believe it's out of this one. I'd have to find the exact reference, but I think it comes out of this, one of the papers in this compendium. Hopefully that helps a little bit. Yeah, I apologize for not having the citation on there.
Oh, and he says, thanks for checking. That does help.
Yep.
And we have another question. Some experts are saying the eruptions are the beginning of a formation of a shield volcano. Is that your thinking as well?
No, not to get a shield volcano, we would need the eruptions occurring in the same place. And what we're seeing so far is a lot of fissure eruptions that are in the same region, but kind of dancing around a little bit. It's possible that if we have several dozen more of these types of eruptions, more or less in this area due east of the Blue Lagoon, that you could start to construct that. But the other thing about shield volcanoes too is it kind of depends a little bit on the topography. On flat ground, it's easier to construct a shield volcano, but if you have a regional slope and all the lava is going to pour out that way, it's hard to make that classic shield volcano if you have, you know, like a more of a slope topography. So I think it's too early to speculate on if something like that's going to take place. I think for now, we're going to see more of these fissure style eruptions probably taking place along the same northeast southwest trend, but possibly changing locations like we've seen a little bit. And so I wouldn't anticipate a shield volcano being constructed anytime soon.
And then another question is, what is the likelihood of the eruptions moving closer to Reykjavik in that area?
Yeah, so there, I think this whole episode, and really starting in 2021, but especially with this threat to Grindavik, has got people thinking a little bit more closely about especially the south and the margins around Reykjavik, not so much the capital area proper, which kind of sits on a peninsula, but if you go to some of the suburbs around Reykjavik, it's obvious it's on younger volcanic terrain. You can see the lava fields and flows. There's not a lot of soil or vegetation there. And so there is some talk, I don't know how far up the food chain it's actually gone, about maybe being proactive and starting to construct lava barriers around those regions, and or also thinking about how we're building out those communities. Like maybe we don't want to put vast neighborhoods close to those, because the Krishuvik system, the next system to the east of what we're talking about with Grindavik, eruptions from that area that were to, if they were to flow to the north, they would impact the capital area. So we have no signs right now that magma has moved in that direction, but we do know that, you know, we're in a new phase of volcanic awakening, I suppose, if you want to give it a fancy term, in this region. And so maybe thinking a little bit harder about how we're going to manage the growth in the communities that are already there.
Oh, wonderful, thanks. One thought I had was you had talked about in one of your initial slides that there was, it looks like maybe this is a dawn of a new centuries-long period of
Yeah, maybe.
volcanic activity. And you just said maybe, is it possible that that activity could just die down and be an anomaly and not harbinger of something long lasting?
Yeah, it's tricky because all we have to go on are those last three episodes, which we know did last hundreds of years on and off. So not always in the same place on the peninsula, not erupting continuously, but the peninsula as a whole having eruptions for centuries on and off. And we only have those three data points. I wish we had a much more extensive set of, eruptive history to look at, because it's bad statistics to base things off of essentially three data points. But it does look episodic, and you can't argue with the fact that there were these eruptive phases, hundreds of years of quiescence with no eruptions, another period of eruptions, and that alternating kind of pattern. And now we've seen just in the last 3 years, 8 eruptions. So there's been 8 eruptions in total in 3 years. So I certainly think the next several years, probably possibly decades, there will be eruptions on the Reykjanes on and off like we're seeing now. Will that go into the hundreds of years time frame? Possibly. It's definitely on the table, but we can't say conclusively. It's more likely to continue, I guess, Rob, than to just shut down right now. We should assume that this volcanic behavior is going to continue indefinitely into the future, and we should plan accordingly. That's probably the best best mindset to have.
And from what you said before, you thought the Icelandic government is doing a good job in trying to anticipate how to jump in front of the lava flows and
yeah, I mean, I'm a US based geologist, but I've been just impressed. I know it hasn't been perfect. I know some of the Icelandic people, maybe in the US and there, might disagree with me, but I think by and large, with all the uncertainty they've faced, I think they've done as well with managing this as can be expected. No one's been, except for one accidental fatality where someone fell down a crack, one of the rescue workers workers in Grindavik. No one has been killed. They have worked out a way for homeowners who want to sell their homes to the government to get good value on their homes. The defensive berms seem to be working well right now, and they've managed to keep all that infrastructure working. Now, how long can they keep this up into the future if we're going to have 15 eruptions in 2025 and 10 in 2026, and that remains to be seen. But I think given this, because it really is like a slow motion disaster, it's unlike a hurricane where it comes, it wreaks devastating destruction, and then it's over and you rebuild and you start over, or even an earthquake where there's destruction and then you restart. I think they've done as well as they can, but at the same time, I think the town, Grindavik, won't be the same anytime soon. The damage to the infrastructure is extensive. A lot of people have chosen to sell their homes, and so that sense of community is maybe going to be changed. It'll be a different town than it was, and I don't know exactly what that'll look like. But I give them the utmost respect and props for the way they've handled the situation in terms of just trying to make those tough decisions, evacuating people, balancing public safety with some measure of flexibility. I just think it's gone as well as can be imagined.
well, thanks. We have one question that I'm going to probably prove you being a better.
I have it up in front of me.
Oh, do you? Oh,
well,
excellent.
Is it the first one from Julian or the second one?
The second one.
Okay. Yeah. So it says, what are your thoughts on another Fagradalsfjall eruption still happening? Now that we've seen Svartsengi's rapid cycling and we saw those 18-hour cycles with the middle phase of the Geldingdalar eruption, it's hard not to notice the 11th month period between the three eruptions there so far, especially since the portion of that dike closer to Keilir hasn't breached the surface yet. I've certainly been wondering about this. I think they're definitely related. So the 2021, 2023 Fagradalsfjall eruptions and this current phase of eruptions are part of the same system. Why did it choose to come up here versus there? We don't know exactly why. The storage zones are a little bit different, but they're definitely connected at depth. So I think another eruption in that location is possible. I'd say even likely, but it's hard to say exactly when it might shift back over to that location. Everyone would like it to. That would be great because then they would have great tourist-friendly eruptions. We wouldn't be dealing with road closures in a town that's threatened. That would be the best case scenario, but it's hard. It's hard to predict. We don't know enough about the subsurface plumbing system. The fundamental. If I could, if I could look in the crystal ball and pick out one piece of data to have, I would like to know exactly what the magma pathways are in the subsurface, exactly what the rock is like, because even though it's all basalt, there's basalt that erupts underneath a glacier that produces one kind of rock. There's regular basalt that makes lava flows. There's lava that erupts from a spatter cone. There's lava that erupts explosively when it's with water. And so there's all these different types of rock. They all have different strengths. Some fracture easily, some don't. And I would really like to see what that rock looks like in the subsurface. If we had a really clear view of the architecture of the rock in 3 dimensions in this region, we could make some much better assumptions and predictions, but we don't. So it's tricky. Really good question, though. Thank you, Julian.
And thank you, Shawn, for incredible presentation today. I know many of us have been following it, and but for you to be able to bring it all together over the months and show us the patterns, that I think has really been helpful, and I really appreciate it, and I'm sure our audience does as well. So we're grateful, and thank you for giving this opportunity to help us learn more about it. And I'd also like to thank all of our viewers for asking these great questions. And before we close today, I want to remind everyone that the recording on this presentation will be available on the INL US and perhaps even on Shawn's website, is one of his thoughts. And the INL US website is at inlus.org. And on the website, you'll find other interesting video presentations and our quarterly newsletter. So check that out. And I do want to again thank Shawn Willsey for this really incredible presentation this hour. Be sure to check out his YouTube channel for ongoing coverage of the Iceland's volcanic activity. And to our viewers, thanks for joining us on this webinar, and have a wonderful rest of your day. And thank you again, Shawn.
Thank you. It was my pleasure.